This is the introduction to section 4.7, congruence in overlapping triangles. Now, we've talked a lot of ways to prove triangles, and essentially what this section is going to do is put everything in there together. Okay, so we got two objectives here: to identify congruent overlapping triangles, and then to prove two triangles congruent using other congruent triangles. Okay, so we talk about overlapping triangles, and a big part of overlapping triangles, overlapping means one on top of the other, okay? So overlapping triangles may have a common side or angle. You can simplify your work with overlapping triangles by separating and redrawing the triangles. So the biggest part for you on these problems are going to be able to identify where the triangle is and being able to redraw it separately. Okay, because what they're going to ask you to do is identify what the common side is in the triangle. So it looks here first, it says here, what common angle do triangle ACD and triangle ECB share? Well, as you look at this picture, it's really, for some of you it may be easy to see this, for others it may not be. So my suggestion to you is to redraw the two triangles separately. ACD. Well, ACD looks vaguely like this, and I'll label this A, then C, and then D. Okay. Now, triangle ECB is the triangle that looks like this. Okay, so E is here, and C is here, and B is here. Okay, these are the two triangles. Now, as you look at the main picture here, you can tell, if it asks you what angle do they share, you can tell that they both have the same angle in C, but sometimes it's really hard to see that when you have them together. As opposed when you separate them, you can tell, okay, which angle do they share? They share the angle that has the exact same letter. Okay? So in this case, they share angle C is what they share. All right. So as we look here, what is the common side of ABD and triangle DCA? So again, I need to separate these. ABD is this triangle right here. So I'm going to redraw that triangle. ABD. And label it. This is A, this is B, and this is D. The other triangle is DCA, and DCA is from here to here to here. So again, I'm going to redraw DCA. Here's D, here's C, here's A. Okay, so those are my two triangles. Now, what you're looking for, what's the common side? What side do they both have that's exactly the same? Well, as you look here, you can see they both have side AD. So side AD is the side that they have that is the same. Okay. So again, it's key to redraw your picture and be able to see these. Okay, what I want you to do is I want you to hit pause on your video and see if you can do this last one before I go through it. Okay, now that you've hit pause, what's the common side in triangle ABD? So ABD, again, it looks like this. ABD, that is, A is here, B is here, and D is here. Okay, and triangle BAC. Now, BAC looks like so. We have B, we have A, and we have C here. Okay, so again, I'm looking for the side that they have that's common, and as you can tell, they both have the side of AB or BA. So the key to finding common sides or common angles is making sure that you redraw the triangles the way they are from the picture, but separate them. Okay, now we're going to involve this into proofs. And when we do this into proofs, it's going to be very important that you know how to identify what triangles you're looking to try and find and use, because they're not going to necessarily give you the proof, and the triangles are not going to necessarily be in the proof. Okay, so as you look at this picture here, okay, and the challenge is going to be able to identify what triangles you're using, because right now you've got one triangle there, 2 and 3, and then you've got the big triangles right here. Okay, so you essentially have 5 different triangles here. And we got to figure out which triangles we're trying to prove congruent. Well, as you look here on these triangles, you'll notice the markings here that you've got a marking for the big angle X and the big angle W. Okay. And you also have a marking for the little angle W and the little angle X, which is what these are right here. Now, it's going to help you see that if you separate these triangles, if you separate the big triangles here, we have Z, W, and X, and we have Y, W, and X, that this is Y, W, and X, and this is Z, and I have Z and W and X here. Again, the key is to separate your triangles and then go ahead and mark them. Well, we know that ZXW, which is this guy, is congruent to YWX, that guy. Those are the single markings. Those are the red markings in the picture. We also know that angle ZWX, angle ZWX is congruent to angle YXW, which is the ones with two markings. Now, if you'll notice, we're going to have to eventually try and prove these triangles congruent. You'll notice we have two angles already. Well, if I can find a side in between, then I'm on my way to finding I can use side angles or use angle side angle. So, as you can see from your first step here is going to be given. We know that those things are true. Now, as you look, do they share a common side? As you're looking at this big picture here, they share the side WX. Now, they may not butt back up to each other like we have in the past, but they do share that side. So I can say in step 2 that WX is congruent to WX by the reflexive property. And I can mark them. Now, I have enough information to prove that the triangles are congruent. I could say triangle ZXW is congruent to triangle YWX by angle side angle. Okay? And then once I have that, now I know that ZW is congruent to YX. And if you look, you need to double check and make sure that ZW and YX are in your pictures. Because if they're not, you chose the wrong triangles then. And they're congruent to each other by CPCTC. Okay? So, this is just a simple example of a proof, and we're going to go through more of these in part 2 of section 4.7, but the key here is to be able to separate and find the common sides. Be able to separate the two triangles and find common sides and common angles as you're looking at section 4.7 part 1. Don't forget to complete your WSQ.